Bravais, oh, an important name in the solid state chemistry. He has a notable contribution in the structure determination. So in 1848, Bravais showed that from geometric considerations, there can be 14 different ways in a similar points which can be arranged in three-dimensional phase. So we have two types of cell parameters now. One is your length, which is denoted by A, B and C, because we have length, width, and height. Similarly, we have angles between the sides. So those angles are being denoted by alpha, beta and gamma. So we all know that a crystal lattice, the total arrangements available are 7, whereas in Bravais lattices, the total arrangement present is your 14. So in the crystal systems with the unit cell parameters, it can be classified as cubic, orthorhombic, tetrahedral and all. So we'll discuss one by one. First we'll take with the cubic. Cubic will have all the sides equal. It will have all sides equal, that is A is equal to B is equal to C. Whereas crystal angles will be your alpha, beta and gamma, and they all are at 90 degrees. So in this, how many Bravais lattice will be there? We have simple cubic, we have face-centered cubic, and we have body-centered cubic. So total 3 arrangements. See, this is the diagram. We have simple or primitive part, then we have your body-centered, then we have your face-centered. So this is how the 3 structures are there. You can see that all the sides are equal and all the angles are 90 degree. Next, we have your orthorhombic, and orthorhombic will have not a single side equal. Neither A is equal to B nor B is equal to C, but all your angles are equal to 90 degree. So in this, we have all the 4 Bravais lattice: simple cubic, face-centered cubic, body-centered cubic and end-face cubic structure. So it will have two-fold axis, which is 3 two-fold axis will be there. So after cubic, we come to orthorhombic. In orthorhombic, neither sides are equal. That means neither A is equal to B nor B is equal to C. But all the crystal angles are equal and they all are equal to 90 degrees. So in this, we have all the 4 types of Bravais lattice, that is simple cubic, face-centered cubic, body-centered cubic and end-face-centered cubic. In this, there will be only two-fold axis, which is 3. You can see we have your simple cubic, we have your body-centered, and we have your end-centered and your face-centered. So in orthorhombic, we have all the 4 types, which is your simple primitive, we have body-centered, we have end-centered and we have face-centered. Now we'll move on to the next, that is your tetragonal. In tetragonal, 2 sides are equal, that is A is equal to B, but they are not equal to the third, that is they are not equal to C. Whereas all the angles are your 90 degree. In this, we have only 2 types of Bravais lattice, that is your simple cubic and your body-centered cubic, in which we have 4 fold axis, that is 1. So this is the simple lattice and it is the body-centered. Next, we'll move on to the next type, that is your monoclinic. Monoclinic will have no sides equal, but 2 angles are equal to 90 degree, that is alpha and gamma angles are 90 degree, but beta angle is not 90 degree. In this, we have only two types of revised lattice, that is your simple cubic and your end face centered cubic. And we have one two-fold axis. So we have your simple and here is your end face centered. Next is your triclinic, and in this triclinic you can see that not a single side is equal and nor the angles are equal. So we have only one, that is your simple cubic. Next comes your hexagonal. Again in this we have two sides equal and the third is not equal. So A is equal to B but they are not equal to C. In this, two angles are equal to 90 degree, that is your alpha and beta, whereas your gamma angle is 120 degrees. And in this we have only your simple cubic structure and only one six-fold axis. Then the last one is your rhombohedral or trigonal, in which your A is equal to B and B is equal to C, but A is equal to B is equal to gamma, alpha is equal to beta is equal to gamma, and they are not equal to 90 degrees. The angles are not equal to 90 degrees. So in this we have only one, that is your simple cubic, and there is only one three-fold axis like this. So now we come over to the various crystal systems, examples of crystal systems which are based on the structures we have just discussed. In cubic system, we have sodium chloride, potassium chloride, calcium fluoride, copper, zinc sulfide, cesium chloride, and etc. Similarly, in orthorhombic, we have barium sulfate, potassium nitrate, magnesium silicon oxalate, then potassium sulfate, etc. Similarly, tetragonal, we have your SNO2, TiO2, ZrSiO2. Monoclinic, we have your calcium sulfate and monoclinic sulfur. Triclinic, we again have your copper sulfate, then your H3PO3. Hexagonal, we have lead iodide, magnesium, cadmium, zinc oxide, etc. And in rhombohedral or trigonal, we have your graphite, then your aluminum oxide, Sb, bismuth, etc. Now we have ionic compounds which can be depicted in three ways. First form is your AB, in which we have only one cation and one anion, that is your sodium chloride or cesium chloride or zinc sulfide, that is one cation and one anion. Next is your A2B type. We can have two cations and one anion, that is your K2O, or it can be AB2 type, in which there is only one anion and two cation, like your CaF2, TiO2 and SiO2. So now we will discuss about the structure of sodium chloride, and commonly इसको rock salt भी कहते हैं. So it is a face centered cubic type जिसका coordination number is 6:6. अगर ना calculate करें the number of atoms of sodium chloride in a cell, we have chlorines at corner as well as in the face centers. So chlorine at corners is 8 into 1 by 8, which is equal to 1. Similarly, chlorine at face centers, we have 6 into 1 by 2, that is your 3. Coming over to sodium at edge centers, there are 12 into 1 by 4, that is 3, and sodium at body center is 1, that is 4. So we have 4 sodium and 4 chlorine atoms. So per unit cell, we have 4 NaCl units which will be present. Similarly, in the structure of cesium chloride, it is of body centered type. The coordination number is 8:8, and the number of atoms per unit cell is 1. In the structure of ZnS, which is a face-centered cubic type, coordination number is 4:4. How it is 4:4? Total sulfur is 8 into 1 by 8, that is 1, plus 6 into 1 by 2, that is 3. So 1 plus 3 is equal to 4. And total zinc present is also your 4. So total ZnS is equal to 4. Red ones are your zinc. Coming over to your calcium fluoride, it is again a face-centered type with a coordination number of 8:4. We have 8 cations and 4 anions. You can see that calcium are your red ones and fluorine are your blue ones. Plus your 6 pink ones again are your calcium. Similarly, here we have blue as your calcium and green as your fluorine. So there are 8 calcium and 4 fluorine in one particular CaF2. In K2O, which is your A2B type, it is your face-centered type again with coordination number of 4:8. In this, we have 4 cations and 8 anions. You can see that sodium, which is being denoted by blue, that is your 4, and your anions, that is your oxygen, which is being denoted by your red ones, and your pink ones, they are your 8. So for this, in the structure of K2O, there are 4 cations and 8 anions. So with this, we end our lecture of today. Thank you.